Hello, in this lecture we find out the value of angle theta. In the drawing we have triangle ABC. Triangle ABC is an isosceles triangle because CA equals to CB. We also know that this angle ACB equals to 80 degrees. This angle NAB equals to 50 degrees in size, and this angle NBA equals to 60 degrees in size. Our mission is to find out the value of this angle NMB that is equal to theta. So we'll focus on triangle ABC. So I copy triangle ABC in a new page and analyze this triangle ABC. So this is triangle ABC that I copied from the original drawing. It is given us in the question that AC equals to CB. Yeah. Side AC equals to side CB. And this angle equals to 20 degrees. We have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. We have the rule that the sum of the angles in any triangle is equal to 180 degrees. Therefore, a triangle ABC, theta plus 20 degrees. In total, all the three angles must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. We subtract 20 degrees from this equation and we get that theta plus theta is 2 theta. It is equal to 180 degrees minus 20 degrees, it is 160 degrees. We divide this equation by 2 and finally we will get that angle theta equals to 80 degrees. So this is angle theta that is equal to 80 degrees. And this is also angle theta that is equal to 80 degrees in its size. So this is angle theta that is equal to 80 degrees. And because of the fact that this angle equals to 50 degrees, the missing angle must be equal to 30 degrees in order to complete this size of this angle theta to 80 degrees. The missing angle must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees. But this angle MBA equals to 60 degrees. So the missing angle must be equal to 20 degrees in order to complete the size of angle theta to 80 degrees. The missing angle must be equal to 20 degrees. Okay, so in the next step we'll focus on triangle A and B. So I will copy triangle A and B in a new page and we will analyze this triangle A and B. Okay, this is triangle A and B that are going from the original drawing. Angle NAB equals to 50 degrees. This is angle theta that is equal to 80 degrees. We define the missing angle as theta. The sum of the angles in this triangle A and B must be equal to 180 degrees. That is to say 50 degrees plus 80 degrees plus angle theta. In total, those three angles, the sum of those three angles must be equal to 180 degrees. 50 degrees plus 80 degrees, it is 130 degrees, so we subtract 130 degrees from this equation, and finally we get that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. So the missing angle theta is 50 degrees, angle A and B equals to 50 degrees in its side. Okay, so in the next step, we focus on triangle A and B. So I will copy this triangle A and B in a new page, and we will analyze it. This is angle theta is equal to 80 degrees. Angle MBA equals to 60 degrees in size. Okay. This is triangle A and B that I copied from the original drawing. We define the missing angle as theta. The sum of the angles in triangle A and B is equal to 180 degrees. That is to say 80 degrees plus 60 degrees plus angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 degrees plus 60 degrees is 140 degrees. So we subtract 140 degrees from this equation. And finally, we get that angle theta equals to 180 degrees minus 140 degrees, it is 40 degrees. The missing angle A and B equals to 40 degrees in its size. We write down in the original note that the missing angle A and B equals to 40 degrees in its size. In the next step, we create line segment BD on AC in such a way that BD will be equal to AB. Okay, BD will be equal to AB. So this is line segment BD that we constructed in such a way that line segment BD is equal to line segment AB. Okay, I write it down. BD equals to AB according to our construction. BD equals to AB according to our construction. I'll copy triangle ADB in a new page and we'll analyze it. So this is triangle ADB that according to the original drawing. Again, AB equals to DB. AB equals to DB according to our construction. This is again data that we found at the beginning of the lecture that is equal to 80 degrees. Those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the same angle must be also equal to 80 degrees in size. So we found out that angle ADB equals to 80 degrees. This angle equals to 80 degrees in size. We continue to focus on triangle ADB. We define this the missing angle as theta. Triangle ADB, the sum of the angles must be equal to 180 degrees. So 80 degrees plus 80 degrees plus theta, in total it must be equal to 180 degrees. 80 degrees plus 80 degrees it is 160 degrees. We subtract 160 degrees from this equation, and finally we get that angle theta equals to 180 degrees minus 160 degrees, it is 20 degrees. Yeah. This angle ABD equals to 20 degrees in its side. This is angle ABD that is equal to 20 degrees in its size. So here angle ABD that is equal to 20 degrees. Angle ABM equals to 60 degrees. So the big angle minus the small angle must be equal to the missing angle DBM. So I write it down. Angle DBM, the missing angle. This is the missing angle DBM. It must be equal to the big angle, that is angle ABM, minus the small angle, that is angle ABD. Repeat again. The missing angle ABD, this angle must be equal to the big angle ABM minus the small angle ABD. So angle DBM equals to angle ABM that is equal to 60 degrees minus the small angle that is angle ABD that is equal to 20 degrees. So 60 degrees minus 20 degrees, this is 40 degrees. So I found out that the missing angle DBM equals to 40 degrees in its size. Angle DBM equals to 40 degrees in its size. In the next step, we'll focus on triangle DMB. So I copy triangle DMB in a new page and we analyze this triangle DMB. This is triangle DMB. This is triangle DMB that I copied from the original drawing. In triangle DMB, we have those two angles that are equal to each other, both equal to 40 degrees. Again, we have the rule that in front of equal angles in the triangle, they are equal sides. That is to say, side DB equals to side DM. DB equals to DM. We have, according to our construction, DB also equals to AB. Then side DB equals to side DM. Side DM equals to side DB. From those two equations, we derive that DB from one side is equal to AB. From the other side, DB equals to DM. From this equation, we derive that DM equals to AB. DM equals to AB. Inside DM equals to AB. Okay, and in the next step, we will join points D and N together by a straight line. And we focus on the green triangle, triangle DNB. Okay, so in the triangle DNB, those two angles are equal to each other. Those two angles are equal to each other. So in triangle A and B, we know that those two angles are equal to each other. And we have the rule that in front of equal angles in the triangle there are equal sides. So I'll copy triangle A and B again in a new page. So actually, this is triangle A and B that I copied from the original drawing. Those two angles are equal to each other. According to the rule that in front of equal angles in the triangle are equal sides, we get that AB equals to NB. AB equals to NB. AB equals to NB. So this side AB equals to NB. Okay. So now I'll copy the great triangle DNB in a new page and we'll analyze this triangle DNB. DB equals to NB. Angle BNBA, angle NBD equals to 40 degrees plus 20 degrees, that is 60 degrees. So actually, this is triangle NBD that I quote from the original drawing. Those two sides are equal to each other according to the rule that in front of equal sides in the triangle there are equal angles. We get that those two angles must be equal to each other because they are located in front of equal sides. So if one angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DNB must be equal to 180 degrees. That is to say theta plus theta is 2 theta plus 60 degrees. It is equal to 180 degrees. We subtract 60 degrees from this equation. You get that 2 theta equals to 180 degrees on 60 degrees, it is 120 degrees. We divide this equation by 2 and finally we get that angle theta equals to 120 degrees over 2 is 60 degrees. So this angle theta equals to 60 degrees and this angle theta it is also equal to 60 degrees in size. Therefore, because of the fact that in triangle DNB we have three angles that are all equal to 60 degrees, we derive from it that triangle DNB is an equilateral triangle. Triangle DNB is an equilateral triangle. That is to say, all the sides of triangle DNB must be equal to each other. So dn equals to nb equals to db in triangle NDB. from one side. From the other side, we have already found out that dm equals to db equals to ab. In the isosceles triangle DNB, dn equals to db equals to nb. So dm actually equals to nb. Repeat again. dn equals to nb equals to db. One side. From the other side, dm equals to db equals to nb. So db from one side it is equal to dn, db equals to dn from one side. From the other side, from this equation, db equals to dm. We can write here that db equals to dm, and from this equation, we will derive that dm equals to dn. dm equals to dn. dm equals to dn. We focus on this side of the straight line CA at point D. Again, we focus on this side of the straight line CA at point D. Which angles we have on this side of CA at point D? First of all, in the isosceles triangle NBD, this angle equals to 60 degrees. So it points on the straight line CA at point D. This angle equals to 80 degrees. This angle equals to 60 degrees inside. Repeat again. On this side of the straight line CA at point D, this angle equals to 80 degrees. This angle equals to 60 degrees. Therefore, the missing angle must be equal to 40 degrees. According to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. On this side of the straight line CA at point D, we have 80 degrees plus 60 degrees is 140 degrees, and 140 degrees plus 40 degrees is 180 degrees, according to the rule. So, this is the missing angle, DMN, that is equal to 40 degrees in its size. In the next step, I will copy triangle NMD in a new page and will analyze this triangle NMD. Get angle DMN equals to 40 degrees. we found out, just like I found out that dm equals to dn. So actually, this is the right triangle, this is triangle DMN, the copy from the original drawing. Angle DMN equals to 40 degrees, and DM equals to DN. Again, we have the rule that in front of equal sides in the triangle are equal angles. That is to say, those two angles that are located in front of equal sides must be equal to each other. So if one of the angles is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DMN must be equal to 180 degrees. That is to say, theta plus theta is 2 theta plus 40 degrees. In total, the sum of those two angles must be equal to 180 degrees. We subtract 40 degrees from this equation, and finally we get that 2 theta equals to 180 degrees minus 40 degrees, it is 140 degrees. We divide this equation by 2, and finally we get that angle theta equals to 70 degrees in its size. This is angle theta that is equal to 70 degrees, and this angle theta equals to 70 degrees in its size. So angle DMN equals to 70 degrees. The big angle DMN equals to 70 degrees. So the big angle DMN minus the small angle DMB must be equal to the missing angle theta, that is the angle that we are looking for. Again, the big angle DMN that is equal to 70 degrees in its size. Minus the small angle DMB that is equal to 40 degrees in its size. Must be equal to the missing angle NMB, that is angle theta. Repeat again, the big angle DMN that is equal to 70 degrees, once the small angle DMB that is equal to 40 degrees must be equal to the missing angle theta, that is actually angle NMB. So 70 degrees plus minus 40 degrees is 30 degrees. So we found out that the size of the missing angle theta, that is actually angle NMB equals to 30 degrees in its size. And that is the answer to the question. In the next step, I will summarize the lecture. So in this lecture we found out the size of this angle NMB that is equal to theta. It's given us the question that triangle ACB is an isosceles triangle, that is to say AC equals to CB, angle ACB equals to 20 degrees in size, angle NAB equals to 50 degrees in size, and finally this angle DB equals to 60 degrees in size. Our mission is to find out the value of this angle theta, that is actually angle VMN or NMB. Okay. So first of all, we focused on the isosceles triangle ABC. This is triangle ABC that I covered from the original drawing. It is given us the question that AC equals to CB. This angle ACB equals to 20 degrees in its size. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front, those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees. Therefore, the sum of the angles in triangle ABC must be equal to 180 degrees. That is to say, theta plus 20 degrees must be equal to 180 degrees. We subtracted 20 degrees from this equation. We found out that 2 theta equals to 160 degrees. We divided this equation by 2 and we found out that theta equals to 160 over 2 is 80. So angle theta equals to 80 degrees. Each of those two angles are equal to 80 degrees in their sizes. So this is angle theta that is equal to 80 degrees. Because of the fact that this angle NAB equals to 50 degrees, the missing angle must be equal to 30 degrees in order to complete the size of angle theta to 80 degrees. The missing angle here must be equal to 30 degrees. Likewise, this is also angle theta that is equal to 80 degrees. But angle DBA equals to 60 degrees. So in order to complete the size of this angle theta to 80 degrees, the missing angle must be equal to 20 degrees. Okay, so in the next step we focused on triangle NAB. So I copied triangle NAB in a new page. This is angle theta that is equal to 80 degrees. This is angle NAB that is equal to 50 degrees, and this is the missing angle. In triangle NAB, the sum of the angles must be equal to 180 degrees. That is to say, 50 degrees plus 80 degrees plus angle theta, in total they must be equal to 180 degrees. 50 plus 80 is 130, we subtracted 130 degrees from this equation, and finally we found out that theta equals to 180 minus 130 is 50 degrees. So this angle theta equals to 50 degrees in its size. Okay, and we have, because of the fact that, so here this angle A and B equals to 50 degrees. So in this triangle A and B we have two angles that are equal to each other, and we have the rule that in front of equal angles in the triangle they are equal size. That is to say, side AB equals to side NB. Again, AB equals to NB. AB equals to NB. AB equals to NB. Triangle A and B. In the next step, we focused on triangle A and B. This is triangle A and B. So I copied triangle A and B in a new page and analyze this triangle A and B. This is triangle A and B that I copied from the original drawing. Angle MBA equals to 60 degrees inside. This is angle theta that is equal to 80 degrees. The angle that we found in the beginning of the lecture. The missing angle, we define the missing angle as theta. The sum of the angles in triangle A and B must be equal to 180 degrees. That is to say, 80 degrees plus 60 degrees plus theta, in total they must be equal to 180 degrees. 80 plus 60 is 140. We subtract 140 degrees from this equation, and finally found out that angle theta equals to 180 minus 140 is 40. So angle theta equals to 40 degrees in its size. So angle A and B equals to 40 degrees in its size. This is angle A and B that is equal to 40 degrees in its size. In the next step, we focused. So here we have already found out that AB equals to NB. Okay, so here AB equals to NB. AB equals to NB. Okay. In the next step, we'll focus on triangle ADB. So this is triangle ADB. So I copy triangle ADB in a new page and analyze this triangle, triangle ADB. First of all, triangle ADB, side AD equals to side DB according to our construction. We built side BD in such a way that it will be equal to AB. So in triangle ADB, we have those two sides that are equal to each other. According to the rule that in front of equal sides in the triangle there are equal angles, we get that those two angles must be equal to each other. So, but this angle equals to 80 degrees. It is angle theta that we found out in the beginning of the lecture. Therefore, this angle must be also equal to 80 degrees. The sum of the angles in triangle ADB must be equal to 180 degrees. That is to say, 80 degrees plus 80 degrees plus angle theta must be equal to 180 degrees. 80 plus 80 is 160, so we subtracted 160 degrees from this equation and finally found out that angle theta equals to 180 minus 160 is 20 degrees. So angle ABD equals to 20 degrees in its size. This is angle ABD that is equal to 20 degrees in its size. So we have the big angle ABM equals to 60 degrees in size. The small angle ABD equals to 20 degrees in its size. Therefore, the missing angle must be equal to the big angle ABM minus the small angle ABD. This missing angle, this is the missing angle DBM. Again, the missing angle DBM must be equal to the big angle ABM minus the small angle ABD. The big angle ABM equals to 60 degrees in size. The small angle ABD equals to 20 degrees in size. 60 minus 20 is 40, so the missing angle DBM equals to 40 degrees in its size. This is the missing angle DBM that is equal to 40 degrees in its size. In the next step, we copy triangle DMB in a new page and we analyze this triangle, triangle DMB. In triangle DMB, we have those two angles that are equal to each other, they are both equal to 40 degrees. So this is triangle DMB that I copied from the original drawing. I repeat again, those two angles are both equal to 40 degrees. Again, we have the same rule that in front of equal angles in the triangle, there are equal sides. That is to say, DB equals to MD. DB equals to MD. I wrote in the original drawing that side DB equals to side DM. Okay, DB equals to DM. Okay, then we join points D and N together by a straight line. I repeat again that in triangle A and B, those two angles are equal to each other. Therefore, in front of equal angles in the triangle, they are equal sides. That is to say, in front of those two angles that are equal to each other, we have side AB that must be equal to side NB. Okay, AB equals to NB. Then we join points D and N together by a straight line. So we have here the green triangle D and B. We focus on the green triangle D and B. This is the green triangle D and B, the core bit from the original drawing. So here angle NBD equals to 40 degrees plus 20 degrees, that is 60 degrees. And we have already found out that DB equals to NB. Okay. DB equals to NB. Okay. DB equals to NB. So here we have the sum rule that in front of equal sizes in the triangle there are equal angles. So those two angles that are located in front the equal sides must be equal to each other. So if one angle is theta, the other angle must be also equal to theta. Okay. So in triangle D and B, the sum of the angles must be equal to 180 degrees. So theta plus 60 degrees must be equal to 180 degrees. We subtracted 60 degrees from this equation and finally found out that 2 theta equals to 180 degrees minus 120 degrees. It is 180 degrees minus 60 degrees, it is 120 degrees. So we found out that 2 theta equals to 120 degrees. We divided this equation by 2 and finally found out that angle theta equals to 60 degrees. So this angle equals to 60 degrees and this angle theta also equals to 60 degrees. Therefore triangle D and B is equilateral triangle. Why? Because all of its angles are equal to 60 degrees. Okay. Repeat again. Triangle D and B is an equilateral triangle. And we know that all the sides of the equilateral triangle are equal to each other. That is to say, dn equals to nb equals to db. N equals to nb equals to db. And we have already found out that dm equals to db equals to ab. So from one side here, we have already found out that dm equals to db equals to nb. dm equals to db equals to ab. dm equals to db equals to ab. And we just right now found out that dm equals to nb equals to db. So from one side, dm equals to db here. From the other side, from one side db equals to dm, here db equals to dm, but from the other side db also equals to dn. From here we can derive that db equals to dn. So from the other side db equals to dn, and from this equation we will derive that dm equals to dn. dm equals to dn. So dm equals to dn. Then I copy triangle DMN in a new page and we analyze this triangle DMN. We found out already that angle DMN, this angle equals to 40 degrees and DM equals to DN. Again, this angle equals to 40 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. And we just found out that dn equals to dn. The sum of the angles in triangle DMN must be equal to 180 degrees, that is to say, but before that, again, dm equals to dn, according to the rule that in front of equal sides in the triangle there are equal angles, those two angles must be equal to each other because they are located in front of equal sides. So if one angle is theta, then the other angle must be equal to theta. So a triangle DMN, the sum of the angles must be equal to 180 degrees. That is to say 40 degrees plus theta plus theta, 40 degrees plus theta equals to 180 degrees. We subtracted 40 degrees from this equation and finally found out that 2 theta equals to 180 minus 140. 180 minus 40 is 140. So 2 theta equals to 40 degrees. We divided this equation by 2 and finally found out that theta equals to 140 over 2, it is 70 degrees. So angle theta equals to 70 degrees in size. So angle DMN is angle theta that is equal to 70 degrees. From this formula we can easily say that angle DMN equals to 70 degrees. That is the big angle. Minus the small angle that is angle DMB that is equal to 40 degrees will give us the missing angle theta that we are looking for. Again, the big angle DMN minus the small angle DMB must be equal to angle theta that is the angle that we are looking for. Again, the big angle DMN that is equal to 70 degrees minus the small angle DMB that is equal to 40 degrees must be equal to angle theta that is the angle that we are looking for. Angle theta is angle NMB. So the big angle is 70 degrees minus the small angle that is 40 degrees. It is equal to 30 degrees. That is angle theta. That is the angle that we are looking for. Okay, so finally found out that the missing angle BMN that is equal to angle theta. It is equal to 30 degrees in its size. Okay, thank you very much.